Well, hi there, boys and girls. I'd like to give a little shout out today to Brandon in third period. Brandon transferred here. When he transferred here, we were about a chapter and a half ahead of his old school in BC Calculus. And I know a lot of students, after one or two poor grades in a class, when they felt behind, and I've actually seen it happen, that would just drop and give up and try something different. I get asked to write a lot of recommendation letters each year, and on those recommendation forms I see things like, how does this student respond to setbacks? And I'm going to give you some adjectives: perseverance, character, responsibility, amazing work ethic, positive attitude, and now you're making A's on my calculus test. Very, very proud of you. And because of you on this December 8th game, Army-Navy, I'll be rooting for Army. Okay, so I want to go ahead and get started with today, and we are going to look at what's called U-Substitution. And U-Substitution is how to deal with integrals without the calculator. You guys should have seen this integral last week when you were trying to do a worksheet, and a lot of you said, well, Mr. G, I can't do this. Even the calculator, when I ask it to find the antiderivative of the sine of x squared, even the calculator says, well, it's just the integral of the sine of x squared. The calculator can't even find an antiderivative. And the reason the calculator can't even find that is because the chain rule was not used here. Now, if there had been a 2x after this, then it's a very easy antiderivative. Let me show you why. If we change this into times 2x and hit enter, now all of a sudden we can do it. Negative cosine of x squared. Now why is this true? When we do the derivative, hit escape here, get out of this. When we do the derivative of negative cosine of x squared, we know that we have to invoke the chain rule. First of all, the derivative of negative cosine is positive sine of x squared, but then we have to multiply times the derivative of x squared. And so that's what we get. So what we're going to do is today we're going to look at how to do antiderivatives when something or something close to the, what I'm going to call the inner derivative, is right next to it. And that's what we're going to work with today. Now later on we're going to figure out what to do with things like this. We're only going to work with functions that we can work with. So let's go ahead and do an easy one. U-Substitution to find antiderivatives. Let's integrate 2x plus 5 times x squared plus 5x to the 7th. Now these may seem hard because there's a lot of stuff going on here, but I want you to try and focus your eyes with practice on something I'm going to call the inner derivative. If you see something that might just be a consequence of the chain rule, then it might not be so hard. So I want you to think about three things for our worksheet. And I'm going to say the integral of u to a power as long as we have du. And I'm going to call it this again. This is the inner derivative. Then this answer is u to the n plus 1 divided by n plus 1 plus c. So let's see if that's the case here. We're going to use U-Substitution in this example. Now what is being taken to a power? Well, the x squared plus 5x, this is what's being raised to the 7th power. So I'm going to see if that's my u. I'm going to let u equal x squared plus 5x. The next thing I'm going to do is I'm going to take the derivative of this u with respect to x, and I get 2x plus 5. Notice what I have in this integral. I've got 2x plus 5 here, but I also have this dx. You cannot ignore this. So I'm going to solve this equation for 2x plus 5 dx by cross multiplying, and I'm going to get that du is equal to 2x plus 5 dx. So watch this substitution. This becomes the integral of u to the 7th. There's my u to the 7th power. And all of this 2x plus 5 dx becomes du. And we have transformed this into a situation where I've got u to a power next to its own derivative. So this answer will be u to the 8th over 8 plus c. then we're going to back substitute what u was. U was x squared plus 5x, so my final answer here is x squared plus 5x to the 8th, that should be an x there, over 8 plus c. Alright, this was an easy one because 2x plus 5 was exactly the inner derivative of this. That is not always the case. Let's take a look at one where that's not the case. Here I've got x cubed plus 5, and I'm going to think about this as my u because it's in parentheses and it's raised to a power. So I'm going to let u equal x cubed plus 5. Now, what is the derivative of that? Well, the derivative of that with respect to x is 3x squared. Man, I wish there had been a 3 right here. If there had been a 3 right here, it would have been perfect. That would have just been a chain rule. But I'm going to show you how to use some manipulation to take care of that. First of all, we're going to solve this for x squared dx because that's what I have left over. We're going to solve this equation for x squared dx. Well, that means I need to divide by 3 and multiply by dx. So I've taken this equation, I brought the dx over here, and I divided by 3 and brought it over here. So this is my substitution for x squared dx. So I have the integral of u to the 6th power times 1/3 du. Now we know from our properties of integrals that any constant can come all the way out in front. So I'm going to do that here. I'm going to call this the integral of u to the 6th du with the 1/3 sitting in front. Now I've got an example of u to the n du. So the way we answer this is we add 1 to that exponent and we divide by that. And then we put a plus c. We can go ahead and simplify this if we want before we back substitute. So simplifying this, I get u to the 7th over 21 plus c. Just multiplying 1 times u to the 7th and 3 times 7. Now we're going to back substitute what u was. U was x cubed plus 5. So this is going to be x cubed plus 5 to the 7th power divided by 21 plus c. And that is right here in A. They just have it 1 over 21. They pulled it out in front. So that required, just a little more manipulation. But again, we're just sticking with that same formula, u to the n. This is a little harder one because we've got a square root. But you can still think about this as the integral of x times 8 minus 4x squared to the 1/2 power dx. So I've got something to a power, and then I've got other stuff that may seem complicated, but believe me, it's going to be nice that it was there. Why is it nice that it was there? Because our examples from earlier. I had the integral of sine of x squared. That seems like an easier integral than this because it's shorter, but it's not easier because the chain rule wasn't there. So in integration, things are going to look real complicated, but we're going to take it a step at a time, and we're going to break it down with U-Substitution, and with practice, this will not be that hard. So let's come back here and do the same example here. What should I do here? I'm going to let u be this thing in parentheses. So I'm going to let u equal 8 minus 4x squared. Now the next thing you do is you've got to come up with the derivative statement because we've got to substitute for the dx. So you do du dx is equal to negative 8x. See that negative 8x. I almost have that. Man, I wish there was a negative 8 right here, because if there was, then all of this would be a perfect du, but it's not. What I have to substitute for is x dx. So I'm going to solve this equation right here for x dx. That means this negative 8 has to come over here, and then the dx has to come over here. So this becomes negative 1/8 du equals x dx. So let's look at our substitution. We now have the integral of u to the 1/2 power. Here's my u to the 1/2. And then x dx is negative 1/8 du. So just like in the previous example, I want to take this constant and I want to pull it out in front. So I'm going to pull it all the way out here. I'm going to have negative 1/8 times the integral of u to the 1/2 du. Well, that's what I've got u to the n du, and so I can go back to my formula, which says add 1 to this exponent and divide by that. So we're going to say that this answer is negative 1/8 times u to the 3/2 divided by 3/2, and then plus c. Now, of course, we're going to have to clean this up. We know that dividing by 3/2 is the same thing as multiplying by 2/3. So let's clean this up a little bit. That is, I can pull a 2 out of that and a 2 out of that. That becomes negative 1/12. And I'm going to go ahead and substitute my u. What was my u? It was 8 minus 4x squared. Negative 1/12 times 8 minus 4x squared to the 3/2 power plus c. So let's go see if we can't find this. Negative 1/12 times 8 minus 4x squared to the 3/2 power. Well, there it is right there. It's c. Okay, so let's do one last one and before we're done. And this one looks a lot scarier because it's a square root in the bottom, but we can still rewrite this as 2x plus 1 to the negative 1/2 power dx. Now here I don't have a number or anything right here, but you could think about it like as a 1 maybe, and the dx is still an important part of this. So let's go ahead and do our U-substitution. This is going to be my u. U equals 2x plus 1. And the next thing we do is we take a derivative of this statement, which says that du dx is equal to 2. Now all I have to substitute for up here is a 1 dx. So I'm going to solve this equation just for dx. So I'm going to get 1/2 du is equal to dx. Just brought the 2 over here and brought the dx over there. So this becomes the integral of u to the negative 1/2. Now I'm going to go ahead and take the 1/2 out in front times 1/2 du. So the 1/2 du was my dx, and there was my u to the negative 1/2 power. And I have my formula again, u to the n du. So this answer is 1/2 times. We add 1 to negative 1/2, you get positive 1/2. And dividing by 1/2 plus c. Now we know that dividing by 1/2 is the same thing as multiplying by 2. That's going to cancel here. So that's going to be 2 times 1/2 times u to the 1/2 plus c. And those cancel, and I just get u to the 1/2. So this is 2x plus 1. I think that was my u to the 1/2 power plus c. Let's go see if that's correct. Yep, it's right here. Because to the 1/2 power, of course, is just the square root of that. Okay, well, that's U-substitution, and you guys will practice this, and I will see you on Monday.